What we're gonna do today is to kind of show you how to really instantiate one experiment on powder, and then how to do a simple transmission and reception using the shell tool that is being specifically designed for powder, so that you can coordinate different nodes, probably more than two sometimes, and then you can have this coordinator to as a server to show that, okay, I want this node as a client to do something to transmit versus receive, and then other nodes as receivers to receive the signal while that one's transmitting, things like that. And right now, this page I'm showing here is called resource availability. You can also find it here. And so what it does is that it will show you what resources are available. So, and this is called rooftop radios. So they're installed on the rooftop, and those are we also call it as base stations. Those nodes are relatively powerful than others, and we also have massive MIMO, dense deployment, all the other node types. I'm not going to go over all those right now, but what I'm gonna do is so you can see that right now, this B is behavioral, and also friendship manner FM. Those nodes are available. And sometimes when you run an experiment, you also have to check their location. So this is the called powder map that we're looking at right now. So it shows that, okay, giving all the node types, you can check okay, this is so base station or rooftop nodes are the ones we're interested in, and we're gonna use them, at least one of them, right? So we want to make sure that those two nodes as transmitter and receiver are not too far away. Otherwise, you will not be able to receive any signal. It's basically just noise. So to make sure that's not going to happen, we are going to check this map. For example, right now, so earlier we saw that friendship manner, this is FM, and then behavioral, BS, those nodes are available. But you can see that, relatively speaking, those two nodes are far apart. You might not be able to transmit and receive. I mean, it's something based on your experience. Is I tend to use maybe behavioral, and then central parking garage. That's a fixed endpoint, another node type. So right now, based after determining okay, these are the nodes I'm gonna use, I'm gonna go ahead and just start this experiment. I'm gonna So I clicked on start experiment, and then you would want to change your profile to this is the one I'm using, and this one has shout tool in it already because it's called shout long measurement. So you can click that one, and then now you're using this profile instead. And then just follow the instructions. For example, we do not need dataset to connect, and then there's this orchestrator that is being used by Shout as a server. And then after based on what I just mentioned, I'm gonna reserve one CBR radio. That's also called rooftop radio or base station. So sometimes we call it by different names. So I'm right now gonna reserve behavioral. I use behavioral, and then I'm gonna also use this fixed endpoint. So I'm gonna use probably bookstore and central parking. I think it's garage. Let me check. So central parking. So it should be this one, and then probably this one. Bookstore and then garage. This house. It should be garage. And then you would also want to specify the frequency. And how can you check what spectrum is available for you to use? You can also go to this resource availability and then scroll all the down to the bottom. And here you can see that these frequencies are being reserved, being used by other people. So you cannot like by other powder users. So right now you're not able to use them. So you can also try like these block maybe 3480 to 3490. And sometimes like that spectrum is being reserved so that you cannot use it. And then if that's the case, then you'll be able to see that reminder saying that, hey, you cannot start to experiment, giving that either the node or the spectrum is being used by other people. And you have your project with different priorities, and then also some like over the air transmission permission, and some projects don't have that. So you might want to make sure that you are using that specific project that you want to have the functionality with. So I'm gonna just call it shout. Okay, so it seems like we are able to start, and then I'm gonna just quick finish and then see if. Okay, so here it says. Okay, so here this is a reminder that we sometimes can see, like it says that this declaration, this 10 megahertz spectrum we want to use is out of range of transmission. So there are two solutions, two options. One, change the node type that you want to use. Do not use those nodes, fixed endpoints. Two, probably change the frequency range. Let me quickly change the frequency and see if we can get around it. 3560 to 3570. So that basically reminds us if we want to use one specific node type, and it feel like a lot of people are using it recently. So one way to like kind of secure your experiment is to reserve the nodes first ahead of time, and then so like instead of on-demand access to the nodes, you have these reservation approved by the group, by the powder group, so that people like no one else can use that node for that time period. So that will guarantee you with access to the nodes and also whatever experiments you want to run. Okay, we'll see if that's okay. Okay, so there is this radio information, which I know is that, so I think it's telling us that knock ones are not are only for receiving. Knock one. So knock one radios are only for receiving. So there is this RX range instead of TX range. So we cannot use them. So because of that, I'm probably gonna just go back and then try to, okay, instead of these, I'm gonna just go use that. The experiment might not be able to, by running the experiment, I might not be able to get any signal measurements, but just to quickly show you how it works, like how to start an experiment, and then also how to use shout to allocate this task to one specific node. So I'm gonna just use two rooftop nodes instead now. Let's see if we have any not available. So if we change it back to frequency range, which is 3480 to 3490. Okay, so seems like all the parameters, all the nodes with frequency parameters are fine. So that's why like all we need to do is just wait till the experiment is ready. And while we wait on that, there are like certain GitLab repos that we can use to learn more about Shout. So first of all, this is the GitLab repo for the profile that I've been using, and this repo belongs to Frost, and so he's PhD student from University of Utah, and since this GitLab repo is public, you can actually fork this whole repo and then load down to this repo to Powder website, and then that can be your own profile, and then you can edit it based on your own needs. So that's one thing. This is the profile we've been using. We just used to instantiate the experiment, and okay. So by click on this is the Shout. This is the Shout tool that we're gonna show later, and it also belongs to Frost. And this GitLab repo is still public, and it shows you this whole Shout tool and how like all the functionalities we have, and sometimes, and also there are like certain data and the examples to show you what kind of data what kind of data format whenever we collect data, and how it will look like. And then there's this whole instruction it says here. So if you click on this, okay, so this is the whole I think called first version. So because Kirk Webb is the one who designed this whole Shout tool, but the repo by Frost, so that is like the up-to-date repo, because so many students, researchers have worked on this Shout tool, so they added more functionalities to the Shout tool. So that's why we prefer to use this GitLab repo so far. And then based on that, I'm gonna go back and see if it's ready. So it's almost ready. So while we wait for that, there's also this whole profile instruction that's very detailed. Like there's a lot of details that you can look into, and it basically shows you how to get access to the get remote access to the nodes, and then run your experiments using Shout. So what it says is that you first instantiating your experiment with appropriate parameters. That's what we just did. And then you have these open SSH sessions that you can use like to get remote access to the nodes. So this is the kind of hosting that you are gonna that's gonna be available to you once this experiment is ready. And then we use SSH to get access to the nodes that you have reserved here, all those nodes, and including this orchestrator, and then all those. So this is the compute node. So that is has this compute resource that you can do this calculation and data storage. Whereas these two are the radio X310. That's the one radio type that can transmit and receive within a very wide 700 megahertz all the way to 6 gigahertz. And if we go back, one more thing is that it uses tmux, and this tmux gives you a new session, open session on the remote node. And the benefit of using this is that once you disconnect from the remote node, your experiment can still keep running. For example, if you want to collect 1 day long data, and then you want to leave your lab office, and because of that, you will no longer have connection to the remote node. But if you have this tmux, it will still keep going and keep collecting data in the back. Whereas if you don't use it, then once you disconnect from the remote node, your experiment will just stop immediately. And so there are two blocks. This one is for getting access to the orchestrator, whereas this command is used to get access to the radio. So the format is the same, but it's essentially two different type of nodes. One is orchestrator, which we consider as server, and then the other is radio, which we consider as client. And then once you get remote access to the nodes, then you are gonna this is optional. Most of the time there's just no problem with that, but if you if you want to make sure that your compute node that you just get accessing to have this radio connected, that the radio can be detected, you use this command to make sure that, okay, we have this radio being detected that we can use to transmit and receive signals. And then the next step is to start the whole shard orchestrator process, which is essentially to start this connection, this whole server client framework. Because right now, nodes are just nodes, and then you have this orchestrator standalone, but you want them to be connected so that the server will be able to transfer all the commands they want the clients to run. So that's why we need this whole orchestrator process. And we have this start orchestrator bash script that will be run on the server side, the orchestrator, and then the start underscore client bash script that will be run on your each of your client node. So if you have two radios, in our case, we have two radios, we have to run this same script on those two radios. If you have two, you have to run all it, or no, it depends on also how many nodes you want to be included in the whole orchestrator process. For example, if you reserved five nodes, but essentially just want to use 4 nodes, then you are gonna just run this start client bash script on those 4 nodes, which is unfortunately not recommended because we have limited number of resources, and we want people to take full advantage of those nodes, of those resources for their benefit. And then the next part is essentially to run your experiment. Once your this whole connection part is ready, then you'll be able to assign all those commands to your clients, and it can be different. And this bash script can essentially tell your clients what commands I want you to run. And then once you finish editing this bash script, so because different people have different experiments they want to run, so you want to make sure that before running this bash script directly, you would want to edit this bash script accordingly to your according to your own requirement. And then once that's done, finished editing, then you're gonna just run this bash script following this command. And it further tells you which directory and how, the name of the data you collected is always called measurement, and the format we're using right now is HDF5 format. And then there's this CMD file that is the file you want to edit, because that's the file that's the command that you want all your clients to run. So that's definitely different. And there's also a log. For example, if your experiment failed, one of your nodes just failed, somehow you cannot get access to it, then it will show up here in this log file, indicating that, okay, this node is not accessible right now, so that the data is not the data collection part using that node is not successful. And also this configuration CSV. And all the if you use bus nodes, bus nodes are being deployed inside all the shadow nodes running around the University of Utah campus. And then if you use those type of nodes, it will also give you these near real-time location CSV file for certain, like for some specific experiments they want to run. And then finally, you can check your safe data set. One note that all these data set will be, so since you first use those client nodes to collect your data, but your data is essentially not saved on those client nodes, they will be transferred automatically to your orchestrator. So you send out your commands, and then you let them run the whatever experiment you want them to run. And then after collecting the data, they will automatically send the data to the orchestrator. So essentially, you only need to work on, like, focus on the orchestrator side, the server side, and then you'll be able to get what the data that you want to collect. And then you can also, there's also this check data Python script that can be used to check if your data is reasonable to some degree. But if you want to really look into that, you might need some other Python scripts. Okay, so right now we can see that the whole experiment should be ready. And what I'm gonna do is I'm gonna go to, so there is this topology view, which shows you if it's ready or not, and also what nodes are there. So right now I have this orchestrator as a server side, and I have 2 nodes as a client side. And if I go to this list view, these are the SS command or like host name that I'm gonna need to get access to the nodes. So I'm gonna currently open my terminal. And it doesn't matter what kind of terminal you use, since we only have 2 nodes. I'm gonna just have 2 tabs open, and this is the client side on the top, and then we have, and now we have server side on the right top and bottom side. And then if I just so orchestrator is 1509. Okay, I'm gonna just quickly get access to it. 14. Okay, so it shows orchestrator, and then session is called shout. Oh. Because I want to make sure those are 2 different sessions, so I should name them differently. So now you can see both are getting access to the orchestrator node, but one session is called shout, whereas the other is called shout 1. And then I'm gonna follow still the same profile instruction. I finished this step, and next step is here, getting access to the client side, like all the nodes on the client side. So 1509. Okay, now you can see here we get access to both behavioral and FM compute node. And following the next profile instruction, we are gonna this step, I'm gonna just quickly use this command. You can also use this one. They're just adding more functionalities to the bash script, but this command is the most important part. I'm gonna just check that we have all those radios connected and also can be detected. Okay, so both clients' nodes show that okay, we have detected this radio connected. Okay, and the orchestrator I did, but it's not necessary because it's just an orchestrator node. We do not have any radio connected. So finishing, so after that step, we're gonna start this whole shout orchestrator process, which is to make sure that all the clients are connected to the server. And so this is the command we're gonna use on the server side. And there's this also this script, bash script should be run on the client side. While that is still going on, we're gonna quickly see the next step. Okay, this is the step that you wanna like edit because this wholly depends on what experiment you wanna run, given what commands, what frequency, what type of signals you wanna run, and then you wanna do it in like a sequential manner. You have 3 nodes, you want them to take turns to transmit, and the rest of them as receivers, or you want them to like do some other stuff. And then if I quickly go to this 3 bash script, you'll be able to see that we have this is the command file. So we have this cmd. This is a command file that you want to run. So you want to use, right now it's called save IQ samples with TX transmitter transmitting some gold code. So that is for direct sequence spread spectrum DSS modulation and DSSS modulation. So that is for one experiment, and you need to change that based on your own experimental design. And one thing, okay, so that's something we need to change. But right now, since it's just an example, we're not gonna change it, but we wanna make sure that the node specification is correct. So what I mean by that is right now we are using these two, FM and BES nodes specifically, but earlier they might just use some other nodes. So we have to make sure the parameters, RF parameters, and then even node names are correct. And the way we do it is to go to this local repository and then, oh, okay, so not sure, I think it's shout. Okay, so it's shout. And then all we can do is do nano local repository shout, and then no, not this. Okay, I have to make the CMD file locate the CMD file path is should be not bin then. Okay, so this is the CMD files that you should store your own CMD file here, and actually it's so it's not here actually. CMD files. Okay, so since we didn't change the CMD file in the run CMD bash script, so what we're gonna do is just simply to make sure that files save IQ. Make sure that, so these are the RF parameters, for example, the command name, if it's time synced or not, and then number of samples that you're gonna collect for each run, and then without transmitter transmitting. So that means you are collecting noise floor to make sure that, okay, compare the actual measurements with this data without any transmission, and you'll be able to see if you actually get some information. If it's the signal strength is very similar, that might be an indication that, okay, you're not getting any signal, actual signal from your transmitter, because it's very close, the received power strength. And then TX rate, that is the rate on the transmitter side, and then frequency, carrier frequency, gain. These are specific to this CMD file. And okay, on the receiver side, sampling rate, frequency, and gain, and then how many times you're gonna repeat. So sometimes you wanna get like 10 or even more, and then you do average, where you try to get spread, some other functionalities. Okay, so here's something I need to change for sure, because it says TX clients and then RX clients. So I need to specify one as not one, maybe since we have two, we can also include both as both here. So if we include both as the into the TX clients and also RX clients, what it does is that well, we choose the first one as the transmitter and then other one as the receiver. Okay, one set of experiments done, and then it will take turns to the other node as the transmitter, and then the remaining node as the receiver, and then do the same experiment. Okay, so we have need to check the name to add it here. So go to the list view, still this experiment page, and then list view, and then you put the name. So the ID, make sure that you put compute node name instead of radio name. I think the other is just FM. Okay, so this is one experimental design. You don't need to add both to the TX clients and RX clients. You can also specify one specifically as TX client and then the other as the receiver client. That will also work. Okay, so I'm gonna save it and then run this final CMD script. And so once this experiment starts, you don't need to worry a lot about the client side, because all those experiments will be handled on the server side. And so sometimes you can see one thing to note, that is sometimes there are errors. For example, right now we saw some errors. And it might be because of your dependency, like some Python libraries you want to use are not there. So you have to make sure that you install them first. And you can also include that to your profile, so that your profile, while instantiating the experiment, your profile will handle everything for you. If you do not do that, then you have to manually install the dependencies you want here on the client side, and then run your experiment. So far we know for a fact that the data we are collecting here is not gonna is not valid, but just to show how we start an experiment on powder and how to run shout, we can see that on the left tab we have all those nodes connected, and it is showing you that we send this IQ RX IQ call. This is the command we want them to run, and then to both, right? And then right now we assign this one FM as the TX, and then the other BS as the RX. and then it will take turns. It will switch. So that's what kind of information we can get from the left tab. On this tab, the right tab, it shows that, okay, we have these total measurements, and then one transmission duration is this amount of time. And then right now we set this RX gain as 50, which is not correct because X310 radios only have this maximum gain as 31.5. So we should change that. And then right now it says, okay, we've done collecting noise floor data, and now we are transmitting from this behavioral, and the gain is 28, and then RX gain is 50, and now we're collecting data. But since the setting, the RF setting is actually incorrect, I'm gonna just stop this experiment. And what I want to further show is that we can see there's this directory that has been created to store all the data that you collected. It's called local data. And then here you see that we have this one folder that shows this is the shout measurements collected using shout, and what timestamp, like date, and also time, like time instance. And then if we further go into that, it shows you log file. As mentioned earlier in that instruction, we have log file, and then measurement, that's the data. And also this is the configuration, like you have all your commands saved, because sometimes you might change it. So you want to make sure that you have this command so that you know you have this configuration file here, so that you know, okay, these are the command that's being used. So after that, so this is what I showed essentially how to start an experiment on Powder, and then second, how to run your experiment using Shout. And then finally, after collecting the data, you would want to offload the data from this remote orchestrator to your local machine, or maybe even upload it to your cloud and then do post-processing. If you want to have some like real-time functionality, then you have to incorporate it into the Shout tool.